Hello guys, welcome back to the QST channel. Today we are going to be solving term physics quiz term 2 week 9 CA quiz for non-transitional year. Okay, let's start. For a body to be at equilibrium, the net force and the net moment around any point on the body must be zero. Which means, like, for example, let's say this is a seesaw. This is the axis or the fulcrum here. If there's 10 newtons going down here, there has to be 10 newtons going down here as well. That's the net moment or net force. So the net force and the net moment around any point on the body must be zero to be at equilibrium. Here the moment, if it's gonna go here counterclockwise and here counterclockwise, 10 newtons, they will cancel out. And for the forces as well, they cancel each other out since they're both same. So it's going to be a balanced force, for example. Pascal law states that the pressure at any point in a liquid is isotropic, which literally stands for, like, let's say, like, it has a physical property which has the same value when it is measured in different directions. Like, it doesn't matter, like, it will always have the same value no matter what direction it's measured in. Okay, on to the next. Fluids exert pressure due to their weight, or here they say on mass, on mass. Here you can use weight or mass, but I suggest use the answer they give you here because it's the most, like, the accepted answer. So fluids accept pressure due to their weight. Okay, on to the next. A girl of a mass 40 kilograms on the right hand side of a seesaw at a distance of 3 meters from its pivot. This is a seesaw. Okay, and another girl of 600 newtons on the left hand side. The right hand side here, 40 kg or 400 newtons, because they say here take gravity 10, and here 600 newtons. The distance from the saw here to from this girl is 3 meters, and they want it to be at equilibrium. So we want 600 newtons times x equals 400 newtons times 3. 600x equals 400 times 3. Put it into the calculator, you're gonna get 2 meters. Alright, on to the next. And before we move on, in the computer part, if they don't ask for significant figures, you don't need to put them. But if they ask, please pay attention for that. Okay, two downward forces, 25 newtons and 35 newtons, are applied to a uniform plank of weight 10 newtons. As shown below, the center of the plank is placed on the fulcrum and the forces are applied respectively 20 centimeters and x centimeters from the fulcrum. The plank is in equilibrium, which means the net moment and net force is zero, which means the net moment is equal to the other, like, net moment of the clockwise motion is equal to the net moment of the counterclockwise motion. The upward force exerted by the fulcrum on the plank. Firstly, we check the forces of the other forces. Here they say two downward forces. Over here, let me highlight it. Over here, 25 plus 35. And they say here the weight of 10 newtons. Here is 10 and here is the other values. So it's going to be 25 plus 10 plus 35. And that answer is gonna be 70. Okay, and for the value of x, the distance, we said net moment equals the net moment of, like, clockwise and counterclockwise. Okay, so what we're going to do is 25 times 20, the order doesn't matter here, equals 35 times x. Let me just write 25x here, okay? If you put it into the calculator, you are going to get decimal. However, here, I don't think there's an extra option, but you just put in 14. Alright, on to the next. Okay, which boxes are in an unstable equilibrium configuration? Here it is just logic. All you need to do is use your eyes and look. Which here is most likely gonna flip over and fall, for example. Right here I can say that block C, it has more grip onto the surface because it has more surface area onto the surface. But block A and B, they barely have surface area on the slanted slope here. So of course you can say that they are going to be in an unstable equilibrium because at any moment they can fall over. Okay? The shapes matter here, okay? Same thing for here, the shape matters as well. The first object, let me just point it out. It has its base or most of its surface area is on the floor, so it's not prone to falling over. Same thing for this one, it's not prone to falling over, most of its surface area is on the floor. For X, for this one, it's a different story, but you can see that it is pretty much balanced. But for this one, if you think of it logically, if you put, for example, your milk carton this way, it's going to fall over, because see here, it's an empty space, so it's going to fall over like this. So it's going to be unstable, so it's going to have an unstable equilibrium. Okay, on to the next. Okay, this one is easy as well. We use the same rule. Net moment of clockwise equals net moment counterclockwise. They ask for the magnitude of x here, okay? We do 50 times 25 equals 40 times x. Well, I don't need to write times, just write 40x. If you put it into the calculator, you're gonna get 31.25. But you check the options here, the closest one is 31. Okay, and they ask for the upward force exerted over here, but it does not show. The upward forces is basically all the forces added up. Here x is 31, here is 50, and the weight is 20. So you do, wait, let me just draw it, 20 newtons. So you do 50 plus 20 plus 31. That's it. On to the next. Okay, the pressure, this is not for like liquid things, this is like solids. Okay, the pressure is equal to force over area or surface area. Okay, here they say the cross section of a shoes, which means one shoe, is 150 centimeter cubed. The weight of the person wearing these shoes is 60 kilograms or 600 newtons. What you do is P equals 600, and before I continue, they specify here shoes, which means both of his legs or both of his feet. You do 600 over, oh, what happened? So you're gonna do 600 over 300, 600 over 300 times 10 to the power of -4, because it's centimeters squared. You want to convert it to meters squared, or to meters squared, yeah. And from centimeter to meter is divided by 100, right? But since it's squared, just add an extra 2 zeros. So it's going to be 10 to the power of negative 4. If you put it into the calculator, you're gonna get 2,000 or 20,000, sorry. And here they want it in scientific notation, so you just enter it this way, alright? Okay, for this one, it's liquid. It's different. Pressure of a liquid is equal to, this symbol stands, I forgot what its name is, but it stands for density times gravity times height. So here they say that if you read the question, they want the pressure of the diver to the surrounding water. So and you have here density, you have the height, and you have gravity. So what you want to do is 10 times 1,020 times 5. You're gonna get 51,000. And they want it here in kilo pascals. And from pascals to kilopascals, from anything to kilo, from like the base unit to kilos divided by 1,000. So you just remove the 0, 0, and it's going to be 51 kPa. Okay? On to the next. Okay, here is easy as well. Okay, here they said that the distance between this person and the fulcrum is 0.8 meters, and he's 60 kilograms. Okay, 60 times 0.8. And they want here to be at equilibrium. Okay? So it's going to be equal to, sorry, I don't do this mistake that I just did. Always convert the 60 kg to newtons. 600 kg equals times 0.8 equals 400x, because you want to find x here. If you plug it into your calculator, you're gonna get x equals 1.2 meters. That's it. And be careful in this question. In the exam, they might give you the values in centimeters. If they ask here for centimeters, convert it to centimeters. If they ask to meters, convert it to meters. Okay? Okay, here unstable equilibrium. It's again logic. Which one of these objects look like they're gonna fall over at any moment? At like the least surface area on their like they have the least surface area on this surface. Just this one, it barely has any surface area, and this one looks like they're gonna fall over at any moment. Okay? Just imagine it as, for example, a Beyblade spinning. Okay? Once it loses its power, خلاص, it's just gonna fall down. Okay? On to the next. The force exerted due to the pressure of a liquid in a container is normal to its surface. Like, imagine this. For example, let's say it's you go to a fancy restaurant. Imagine this as a fancy water bottle, for example, like the glass ones. Okay? This is the water. It's always, the pressure exerted is always, like let's say this is the point, it's always normal to its container. Okay? On to the next. Pressure is a scalar quantity equal to force per unit area. Okay, pressure is scalar because it can't have a direction. As we said, it's isotropic. No matter from what direction you measure it from, it will always have the same value. Okay, so pressure is scalar. It's equal to force per unit area. P equals F over SA. Okay, as we said, force over area, but we call it surface area. Okay. Okay, the U-tube manometers are used to measure the pressure of water. this is memorization. On average, a human body can withstand a maximum of 1.8 times 10 to the power of 5 pascals of pressure due to water. If the density of salt water in the sea is 1.03 times 10 to the power of 3 kilograms per meter cubed, and the acceleration due to gravity is 9.8 meters per second squared, then the maximum safe depth that the average human can dive to one decimal place is, okay. As we said, in liquid, pressure is equal to density times gravity times height. Here they said the maximum pressure that a human body can withstand is 1.8 times 10 to the power of 5. So P is equal to 1.8 times 10 to the power of 5 equals, what is the density? The density of salt, if you read here, is 1.03 times 10 to the power of 3. And the acceleration due to the gravity is 9.8. So use the gravity here, 9.8. And the height, we want to find it, so use x. If you plug it into the calculator, yeah, you get 17.8. Okay, on to the next. Okay, this one might seem challenging, but in reality it's really easy. Okay, the diagram below shows a uniform lever of length AB 60 centimeters pivoted at point O, which is located 25 centimeters from point A. The lever is balanced by a mass of 80 grams attached 10 centimeters away from A. Look here, since they want the value in grams, okay, we don't need to convert it to kilograms, okay? So what you're gonna want to do is, since it's going to be at equilibrium, if I'm not wrong, yeah, they wanted to balance. Here the pivot has to be like when you're gonna calculate, you have to calculate how far the pivot is from the center. Here we can see the pivot is 5 centimeters because it's here is from A to the pivot is 25. So from O to the center is 5 more, because from A to B is 60. 60 minus 25 is going to be 35. It's 5 away. Center is 30. Okay. So what we want to do is not 25. The distance from this object to O is going to be 25 minus 10. So it's going to be 15 times 80 equals 5x, because the mass of the pivot is x. We want to find it. And the distance from the pivot to the center is 5 centimeters. If you plug it into the calculator, you're gonna get 240 grams. That's it, as simple as that. Okay, on to the next. James has a mass of 80 kilograms. If he stands on 1 foot and the area of his shoes is 200 centimeter squared, then the pressure exerted by his foot on the ground is 4 times 10 to the power of, okay. So here what you're going to want to do is, here they say of his shoes, if he stands on 1 foot, the surface area of his shoes is 200 exerted by his foot on the ground. Okay, they want to know the pressure exerted by his foot. So it's going to be pressure equals force over surface area, or just area, whatever you'd like to call it. The force is, they take gravity 10 newtons, so we do 800 over 200 centimeter cubed squared converted to meters times 10 negative 4. Okay, you do 800 over 200 times 10 to the negative 4. You're gonna get 40,000. Here they ask you to convert it to scientific notation. So 1, 2, 3, 4. So it's going to be 4 times 10 to the power of 4 PA. But wait, look, here they ask for PA, but if they, in the exam they ask you for KPA, you divide it by 1,000 to convert it to KPA, okay? On to the next. When a man stands on the floor with both feet, he exerts less pressure than he is standing with one foot. If you think of it logically, okay, like, let's say I am here, this is somebody, this is a person. He's standing on both of his feet. The weight, his downward force, which is the weight of his body, is going to spread from through this leg and this leg. Let's say he weighs 80 kilograms, for example. Okay, 400 newtons here, 400 newtons here. Okay, logically, his weight is going to be split through both of them. But if this person is standing on one leg and he's still 80 kg, all this weight will be put on his leg. 80 kg down, 800 newtons downwards, for example, here. Okay, so that's why if he stands on the floor with both feet, he exerts less pressure. You can think of it logically in the exam like this. Okay, 400 newtons, 400 newtons. That's it. All right, on to the next. Sorry about that. Okay, the pressure is measured using a pressure gauge. Like the pressure is measured using a pressure gauge. This is memorization. Liquid can be measured using a simple gauge called the YouTube manometer. It's all memorization. All right. Okay, the pressure at point A in the syringe is a force of, let's read the question first. A force of 5 newtons is applied to a piston of a syringe filled with water. The length of a syringe is 3 centimeters and its cross-sectional area is 2 centimeter cubed. Squared. As shown in the diagram below, we agreed on that pressure is equals to force over area, surface area. Here the force is going to be 5 over the surface area. Here is going to be 2 times 10 to the power of negative 4. Okay, that's it. Plug it into your calculator. 2 times 10 to the power of negative 4. You're gonna get 25,000. Converted to kilopascals, you're gonna get 25 kilopascals. The pressure at point B in the syringe is okay, for point B it doesn't matter. It's both gonna be the same force going there and the same surface area. There's no difference, that's why it's going to be the same. Okay, let's go to the next question. In a liquid of density, okay, the pressure due to the liquid at a given depth H is PGH. This is the rule of in a liquid. Okay, if they give you like a liquid's density and the pressure of a liquid, like they want you to find the pressure, use this rule for liquids. But if it's like, as we said, like solids, use P equals F over SA, which is force over surface area. And here it's just density times gravity times height. Alright? as depth increases, the pressure in a liquid increases. Like, think of it like this. Let's say, for example, this is the Mariana Trench, for example. Okay, this is all the water. Okay, let's say you are swimming here. You're swimming here. There's the only forces that are acting from you is the water, like this at a normal. Okay, it's only like, for example, this section of water that's gonna act on you. But if you are here, for example, you are swimming down there, all of the water over here up above you is going to put a pressure on you. So the deeper you go, the more pressure that's gonna act on you. Like, the more pressure there's gonna be. Not onto, it's like it's going to be going onto the walls like this. And you're probably gonna be caught in between them. Okay? Thank you guys for watching the QST channel. I hope you guys have the best of luck in your exams. Please study well and have a good rest of your day or night.